All right, let's dive in. Today we're going to be exploring something pretty fascinating, fine-tuning large language models. You know, those super smart AI systems that seem to be popping up everywhere.
Yeah, they power everything from chatbots to, well, you name it.
Exactly. Now, you might be thinking, these things are already brilliant. What's left to teach them? Well, the real question is, how do you teach an AI something new after it's already been trained on, like, mountains of data?
That's where fine-tuning comes in, right? It's kind of like giving an already pretty smart LLM a specialized crash course.
Exactly. Imagine being able to just teach an LLM, say, the latest medical guidelines or update its knowledge on a brand new coding language.
It's a pretty exciting concept, right? I mean, we expect people to constantly be learning and adapting, so it makes sense that we'd want LLMs to do the same.
Absolutely.
Yeah.
And companies like OpenAI and Google seem to think so too. They're offering these APIs that promise to let you fine-tune their LLMs. Sounds pretty slick, doesn't it?
Yeah, on the surface, it seems like a pretty elegant solution.
But some brand new research from Stanford University suggests it might not be as straightforward as it sounds.
Yeah, this research is really important because it kind of highlights a key challenge in the field of AI. Even with these fancy fine-tuning APIs, getting LLMs to truly absorb new information is surprisingly difficult.
Okay, so they didn't just ask the LLM, hey, what's 2 plus 2? They actually put these APIs to the test.
Oh yeah, they created a whole benchmark called Finetunebench.
Finetunebench.
Yep. And they used it to see how these APIs would handle different types of knowledge. They tested everything from like the latest news to medical guidelines. They even threw in some fictional information
Wait, fictional information, why?
to see how the LLMs would handle something completely made up, something that didn't exist in their original training data.
Oh, that's clever. So, like, testing the LLM's ability to, I don't know, gossip about made-up celebrities.
Well, not quite gossip, but you're getting the idea. They wanted to push the boundaries of what these LLMs could learn.
I like it. Okay, so what did they find? Did these LLMs pass the test?
Not exactly. Across all the models they tested, the average accuracy for learning new information was only 37%.
37%.
Ugh.
That's not great.
And it gets even worse when you look at updating existing knowledge, things like medical guidelines or code frameworks. For those updates, the average accuracy plummeted to just 19%.
Hold on. So you're telling me these incredibly sophisticated AI systems, the ones everyone's raving about, struggle to learn new things,
Yeah.
and updating their knowledge is even harder.
That's what this research suggests. It seems that fine-tuning, at least in its current form, isn't the magic solution we might have hoped for.
Okay, I'm officially intrigued. Let's unpack this. What kinds of LLMs were they testing?
They included some of the biggest names out there: GPT-4o, GPT-4o Mini, GPT 3.5 Turbo, Gemini 1.5 Pro, and Gemini 1.5 Flash. A real all-star lineup. And they tested them in two key ways. First, they looked at how well the LLMs could learn entirely new information. And then they tested how effectively they could update knowledge they'd already been trained on.
And that's where things really went south, right? That whole updating existing knowledge thing. Why do you think that is?
Well, one possibility is that the original training data is so ingrained in the LLM structure that it's really difficult to overwrite.
Ah, so it's not just about teaching the LLM new facts. It's about getting it to unlearn or modify old ones.
Exactly.
That sounds tricky.
It does, and the researchers haven't found any easy fixes yet. They experimented with different ways of, presenting the information during fine-tuning, but nothing significantly improved the results. But here's where it gets really interesting.
Okay, hit me with it. What's the twist?
The smaller LLMs, specifically GPT-4 and Mini, were actually the most effective at both learning and updating information.
Whoa, really? You'd think the bigger, more complex models would be better learners.
You would, but it seems that in the realm of fine-tuning, at least for now, smaller might be mightier.
Fascinating. So we know that fine-tuning isn't a perfect science, and that updating knowledge is especially tricky. But what does this actually look like in practice? Can you give us an example?
Absolutely. Remember how I mentioned they used fictional information in this study?
Yeah.
Well, one of the examples they used was a baseball game. They taught the LLM the first pitch temperature of a specific game, and it learned that information perfectly.
Okay, so far so good. What's the catch?
Well, then they asked the LLM about the first pitch temperature for a game that took place 6 years in the future.
Nah.
It confidently repeated the exact same temperature.
No way. It's like the LLM got stuck in a time warp or something.
Exactly. This example highlights a key challenge with fine-tuning. It can lead to what's called overfitting, where the LLM becomes so good at memorizing the specific training data that it can't generalize that knowledge to new situations.
Okay, I'm starting to see why updating existing knowledge is such a problem. It's like the LLM is clinging to its old beliefs, even when they're outdated.
That's a great way to put it. And it has some pretty significant implications for anyone hoping to use LLMs in dynamic fields like medicine, law, or software development, where information is constantly changing. But we'll delve into those implications more in part 2 of this deep dive.
Welcome back. Remember that baseball game example from part one?
Yeah.
The one where the LLM confidently predicted the same first pitch temperature for a game 6 years in the future.
Yeah, it's a perfect illustration of why updating LLM knowledge is so tricky.
It gets stuck on what it's already learned, even when it just, well, it doesn't make sense.
Exactly. That tendency to overfit to the training data, that's a major hurdle in fine-tuning, especially when we're talking about updating existing knowledge. It's like those old facts are kind of etched into the LLM's neural pathways, and, well, it takes a lot of effort to rewrite them.
Okay, so let's dive back into the Stanford research and try to understand why this is happening. You mentioned they used this benchmark called Finetunebench, right?
Right, Finetunebench. Yep, it's a framework they developed to test how well these commercial fine-tuning APIs work. They created 4 distinct datasets. Each one represents a different type of knowledge.
Okay, lay it on me. What kind of knowledge domains did they test?
So first, they had the latest news dataset, which focused on, well, recent news events. Think headlines, breaking stories, that sort of thing.
So they were basically testing if the LLM could keep up with the 24-hour news cycle.
Exactly. Then there was the fictional people dataset.
Fictional people.
Yeah, this one's a bit more interesting. They created entirely fictional characters with specific attributes, like height, weight, occupation, hobbies, you name it.
Wait, so they were testing the LLM's ability to, learn about characters in a made-up novel?
It is, yeah. The idea was to see if LLMs could absorb information about something that didn't exist in their original training data.
I'm starting to see why they called it Finetunebench. They really put these APIs through their paces. Okay, what were the other 2 datasets?
The third dataset was all about medical guidelines. Think updates to recommended treatments, dosage changes, new best practices.
This one feels pretty important, given all the talk about using LLMs in healthcare.
Absolutely, and the results from this dataset were, well, particularly eye-opening.
Okay, tease. What was the final dataset?
The last one, the code dataset. This focused on adapting to changes in coding languages and frameworks.
Okay, so they covered a pretty wide range of knowledge domains, from the latest news to made-up people to, the very technical world of code.
Yeah, they wanted to get a holistic view of how well these fine-tuning APIs work.
Right. And they didn't just test if the LLMs could memorize these new facts. They also looked at whether they could generalize that knowledge, apply it in different contexts, answer related questions, make inferences.
That's where things got really interesting.
Okay, enough suspense. Give us the goods. How did the LLMs perform on these different tests?
Well, as we mentioned in part 1, GPT-4o Mini, the smallest LLM they tested, that was a surprise standout. It consistently outperformed its bigger, more complex siblings, both on learning new information and updating existing knowledge.
So the little engine that could. I love an underdog story. What about the others? Any consistent patterns emerge?
The most consistent finding across all the models and all the datasets was that updating existing knowledge was significantly harder than learning brand new information.
Why do you think that is? Is it just that those initial training datasets are so, deeply embedded in the LLM's structure that it's just hard to overwrite them?
That's definitely part of it. It's like, trying to teach an old dog new tricks. They've already got their habits set. But there's probably more to it than that. I mean, we're still in the early stages of understanding how these LLMs learn and adapt.
All right, let's break this down by dataset, starting with code, because I'm guessing that one presented some unique challenges.
Yeah, you're right. The code dataset, that was a particularly tough nut to crack for these LLMs. Remember, code is very precise and structured. Even a small change, like renaming a function, can have a ripple effect, throughout the entire code base.
Yeah, it's not just about swapping out one word for another. The LLM needs to understand how that change impacts the overall logic of the code, right?
Exactly. It's like living a new word in a foreign language. You can memorize the definition, but you also need to understand how to use it correctly in different grammatical contexts. And the LLMs really struggled with this aspect of code updates. They could memorize the new function name, but often failed to use it correctly when generating new code.
Yikes. That doesn't sound good. Imagine relying on an LLM to help you write code, only to have it introduce a bunch of errors because it didn't fully grasp the implications of, the changes you made.
Yeah, it highlights the limitations of simply, memorizing new information without truly understanding how it fits into the bigger picture.
Okay, let's shift gears to the medical guidelines dataset.
Yeah.
This one feels particularly relevant, given all the buzz about using LLMs in healthcare.
Absolutely. And the researchers found some, well, concerning results here. The LLMs, they did show some ability to incorporate new medical guidelines, but their performance was inconsistent. In some cases, they would learn a new guideline perfectly, but then fail to apply it correctly when presented with a hypothetical patient scenario.
So they knew the rule but couldn't figure out how to use it in the real world.
Exactly. And that's a big problem if you're relying on an LLM to provide accurate medical information or assist with diagnoses.
All right, 2 down, 2 to go. How did the LLMs fare on the latest news dataset? This one seems a bit less high stakes than, code or medical guidelines.
You'd think so, right? And it was the data set where the LLMs performed the best overall. They were able to learn about recent news events and answer basic questions about them with a reasonable degree of accuracy.
So they could, keep up with the latest sports scores or tell you what happened on Wall Street?
Exactly. But even on this seemingly simpler data set, there were some limitations.
Really? Like what?
Well, when the researchers tested the LLMs by rephrasing the questions about the news events, asking the same question in a slightly different way, their performance dipped. They could answer a direct question like, who won the Super Bowl? But they struggled with a more nuanced question like, which team emerged victorious in this year's Super Bowl?
Ah, so it's back to that problem of memorization versus understanding. They could regurgitate the facts, but they couldn't adapt their knowledge to different contexts.
Exactly. And that kind of highlights a key challenge in developing truly intelligent AI systems. It's not enough to simply stuff them with information. We need to find ways to teach them to think critically, to reason, to generalize their knowledge to new situations.
Okay, you've got me hooked. We've explored 3 of the 4 datasets used in the Finetunebench study code, medical guidelines, and the latest news. That leaves just one, the fictional people dataset. What insights did they glean from testing the LLM's ability to learn about, well, completely made-up characters? All right, welcome back for the final part of our deep dive. We've been exploring fine-tuning LLMs and, the challenges that come with it. We've talked about code, medical guidelines, news, and I think, we even ventured into the world of fictional characters, right?
Yeah, that's where we left off with that fictional people data set from the Stanford research.
Right.
Remember they created these completely made up characters to see if the LLMs could learn something that, well, that didn't even exist in the data they were originally trained on.
Right. It's like giving them a crash course in a brand new fantasy world.
Yeah.
Did they pass the fiction test?
It's interesting, actually. The LLMs were good at memorizing the details. They could tell you a character's height, weight, even things like their favorite color.
Okay, so they aced the basic trivia round. But we know from the other data sets that, well, memorization isn't the same as understanding. How did they test for a deeper level of comprehension?
They started asking more complex questions, the kind that requires the LLMs to make connections between different pieces of information.
Okay.
For example, they might ask, is this fictional person taller than this other fictional person? Or would these two characters likely be friends based on their shared interests?
So it's not just about knowing the facts, but understanding the relationships between them. Did the LLMs rise to the challenge?
Not quite. They struggled with those more nuanced questions. They could remember the individual facts, but they just couldn't make connections or draw inferences.
So they could tell you that character A is 6 feet tall and character B is 5'8", but they couldn't figure out that character A is taller.
Yeah, exactly. It's like they had all the pieces of the puzzle, but they couldn't put them together to see the bigger picture.
That makes sense when you think about it, right? Human understanding goes beyond just storing facts. We make connections, draw inferences, and that's something that current LLMs, well, they just seem to struggle with.
Yeah, you're right. And that's a crucial insight for anyone working with or developing LLMs. We need to be realistic about their current limitations. They're incredibly powerful tools, but they're not a replacement for human intelligence, not just yet.
So fine-tuning has its limitations, but AI is evolving so rapidly. What are some, potential avenues for improvement? Could we teach these LLMs to think more like humans, to make those connections and inferences that currently they can't get?
Well, that's a million-dollar question. Researchers are exploring a number of promising directions. One approach is to move beyond simply feeding LLMs more data, and towards developing more sophisticated training methods. Instead of just showing them the what, we need to teach them the how.
So less rote memorization and more critical thinking.
Exactly. Like, imagine training an LLM not just on facts, but on the processes of reasoning, deduction, problem solving.
That's fascinating. What other approaches are being explored?
Another exciting area is developing, more specialized LLMs. Instead of trying to create one giant model that, knows everything, we might see a shift towards smaller, more focused models that are fine-tuned for specific tasks or domains.
So kind of like having an LLM that's an expert in like cardiology, another one that's a whiz at, writing legal contracts.
Okay.
Okay. So the future of fine-tuning is still unwritten, but it's clear that there's a lot of potential for growth and innovation. Any final thoughts?
I think the key takeaway here is that we're still in the early days of LLMs. It's an incredibly exciting field, but we need to be both, enthusiastic and cautious. We should celebrate the advances that have been made, but also, acknowledge the limitations and the potential risks.
Well said. Well, that brings us to the end of our deep dives. We've explored the challenges, the possibilities, and even had a little fun along the way. Remember, the world of AI is constantly evolving, so stay curious, stay informed, and who knows what incredible breakthroughs are next. Thanks for joining us.